Hey guys, welcome back. So in this video, we'll be discussing on the second problem of thermal analysis. So this problem particularly is a composite wall and it has a fixed temperature of 20 degrees Celsius on the right side and the convection temperature on the left part. So this is the difference between the first and the second problem. And we need two parameters for the convection part, which is film coefficient and bulk temperature, which is given, and the fixed temperature for the right part is also given, and the thickness of each distributions are also given in the problem. So we'll be finding out the rate of heat loss from the composite wall and the wall interface temperatures. And yeah, let's start the thermal part in the ANSYS folder. Hey guys, welcome back. So let's start the thermal part of second problem in the ANSYS. Going on with the selection of preference of thermal and adding the element type, which is solid 8 node 77. Next, we'll not be adding any real constant. We're just going to the material properties, material models, and we'll be adding three models here. One with thermal, conductivity, isotropic. So the conductivity for first model would be 20. Clicking on OK. So let's create another model, which is a new, and define it as 2. Now we'll just add the conductivity, which is 30. Click on OK, and we'll be defining another new model. Now again assigning the conductivity, which is 50 for the third model. Clicking on OK, and once after we add every three models, so we can just close this, going with the modeling to create the areas. So create areas rectangle by two corners. So the coordinates for the initial first would be 0, 0 along x and y, and the width is 0.3 as per the given, and we can assume the height as 1. Clicking on apply, and now for the middle one, which is whose coordinates is 0.3 along y-axis, along x-axis, and y-axis is 0, and the width for this would be 0.15. Clicking on the height, which is 1, and apply. Now the third area is 0.45 along x-axis and 0 along y-axis, and the width is 0.15 again, and the height is 1, and click on OK. So now we have added the areas. We'll just glue them. Going on to the operate in the same modeling section, booleans and glue areas. So just click on pick all. So after this operation, we'll be moving on with the meshing. In meshing, we'll be assigning each material model for each area, so respective areas. So just going on to mesh attributes, default attributes. So element type would be given. I'm sorry, we'll go with the picked areas. So once we pick the first area, clicking on apply. So by default, the material number will be selected as 1. Let's keep it as it is because it is what we wanted. And for the second one, clicking on apply, we'll need to change this to 2. So because we have assigned the material models as per the arrangement of the composite. So clicking on apply again. The third area, clicking on OK with the third model number and clicking on OK. So once we have done with the mesh attributes, we can go with the mesh areas and click on free, just pick all. So this completes the mesh part. Now we can go to the loads, assigning of the loads. In loads, we'll be assigning two different loads here. So define live and thermal. So in thermal, in temperature, and we'll go with the onlines. So we'll just select the right part of this whole rectangle. Just clicking on that and OK. We'll have to select the D10 and the load temperature value should be 20. Clicking on OK. We have assigned the temperature load. For that, we'll be going to convection inside the thermal. So in convection, we'll go with the onlines. So we'll be selecting the left part offline. So just clicking on OK. We'll be asked two values for here, which is film coefficient and the bulk temperature. So the film coefficient would be 25 and the bulk temperature would be 800. So these values are actually given. So after entering these values, you can just click on OK. So after assigning the convection thermal load, we can go with the solutions. So in solution, solve and current ls, we'll get the node as solution is done. Now we can proceed to general post processor. So in general post processor, we'll be getting to counterplots, nodal solution, and the dot solution and the nodal temperature. Clicking on OK, we'll get this particular heat map. So now we'll have to go to query result, subgrid solution, and click on OK. So we'll have to pin at a point. So this is the temperature at this exact surface, and at this point, at the middle of middle rectangle and the right side area, at last the last rightmost endpoint. So these are the temperature values which we have. If you can just zoom in. So those values are to be noted. And let's move on to the next part, which is again going on to the plot results and getting the vector sum. So going to plot results, nodal solution, in thermal flux, click on thermal flux vector sum, clicking on OK, you'll get a red overlay or a composite going on. So we'll be going to path operations. In path operations, we'll be defining path and nodes by nodes. So clicking on the first, second, and third, fourth. Clicking on OK. Just will define the lab name as temp. OK. And now we'll go to the map onto path. Here again we can give the over level as temp. Clicking on OK. Make sure the default values have been selected as it is. I'm going to plot path item. So on graph, and we'll be selecting the temp label. We should get this exact graph, and we can copy down the node 1 and node 2 values. This completes the second problem of thermal analysis. Thank you for watching.